How Twitter handles 500 million tweets per day. Every second, around 6,000 tweets are sent. That comes down to 3.6 lakh tweets per minute, 500 million tweets a day, and approximately 200 billion tweets every year. But how does Twitter actually handle this insane amount of data without breaking? Let's go behind the scenes and break it down in simple terms. So let's go back to the time in the year 2008 to 2009. So for your information, Twitter was launched in the year 2006. And by that time, the user growth was approximately 1400%, and users were spending 175% more of their time on the platform. So let's talk about the initial tech stack of the Twitter. So Twitter was basically on Ruby on Rails and they used MySQL for storage. It seems to be a great choice for startups because it's fast to develop on. But when you scale to millions of tweets a day, Ruby on Rails starts to break. Performance slowed, downtime increased, and user began to see the infamous fail whale error message. An error message showing a whale being lifted by birds, as you can see on the screen. Then the team decided to migrate from Ruby on Rails to Java and Scala. So when they did the migration, these are the results, and the results are seriously insane. It's around 100x improvement in performance. So as we can see, with Ruby, they used to send 200 to 300 requests per second per host, but with Java, they were able to send 10k to 20k requests per second. And the farewell officially retired in the year 2015. And talking about Scala, Scala runs our Java Virtual Machine, JVM, basically, for better concurrency and performance. And they're also using Apache Mesos, that is basically for resource allocation and cluster management. And then further, after migrating to Java and Scala, they move to microservices. So they break down all of their monolithic architecture into microservice architecture. Moving on to the real time data processing. So they started using Apache Storm to process millions of tweets per second, as we've mentioned. So how it works is user tweets and the tweet goes to the Apache Storm. So it basically takes tweet as a stream of data, run multiple small tasks in parallel, basically filtering, spam, ranking, updating timelines, and whatever the result that we get from the Apache Storm, the tweets are pushed to the timelines, trending list, and search indexes. So let's go and dive into some technicalities of the Apache Storm. So basically, Storm organizes the data into topologies, and we call this spouts and bolts. So basically, it's a network of spouts and bolts. So what are spouts? Spouts are sources of streams, basically incoming tweets, and bolts are the processors that filter, transform, and aggregate, or basically route the data. Moving on to the machine learning and Python enhancements that Twitter adopted. So, to make the timeline smarter, Twitter invested heavily in machine learning, and Python became the choice for building data pipelines, running batch analysis, and training their ML models. Python isn't used for high speed backend services, but it definitely plays a huge role in intelligence behind the scenes. So, let's talk about storage. So their traditional storage systems couldn't handle Twitter when it scaled. So in 2014, they built Manhattan, their distributed multi-tenant key value store designed for high availability and low latency. If you didn't understand this, don't worry. Let me elaborate it in simple terms. So in simple terms, Manhattan was their own custom storage system. So you can think of it like a super smart library that spreads data across many locations. And why? So that it can store more and retrieve faster. Keeps working even if part of it fails. and deliver results instantly. So basically, high availability and low latency. And apart from this Manhattan, they were also using Hadoop for heavy analysis. And Hadoop is perfect for analyzing trends, generating ML, training data, and doing compliance audits. But let me tell you one thing, Hadoop isn't real time, it is batch processing. So, coming to the cloud migration and hybrid strategy that Twitter followed. So, by 2022, Twitter started moving to Google Cloud Platform. But why? Because we all know managing infrastructure at a global level is really very tough, and that too when you have millions of active users per month on your platform. So, adopting cloud provides better agility, lower latency, and flexibility for scaling traffic spikes, especially during events like election or some sale or some issue or some protest. So, that was about cloud migration and hybrid strategy. Let's move on to search and indexing. So, whenever it comes to search, most of the Fortune 500 companies use Elasticsearch, but Twitter use it with a twist. So, they basically use a reverse proxy layer to split read and write traffic. So, this helped them to keep their search fast and efficient. So, you can imagine Twitter's search system as a huge library. So, basically, if you're looking up for books, you can consider it as searching for tweets. And if you're adding new books to the library, consider it as posting new tweets. So this is read traffic and this is write traffic. And if both happen at the same time, things will get really messy and slow for the consuming users. So how Elasticsearch helped it? Let's see. So you can think of it like a librarian who directs traffic. So the read traffic goes to the search desk and the write traffic goes to a different desk to handle, update, and store new tweets. And all of these enhancements help Twitter scale a lot more better. Now let's see how Twitter evolved after Elon Musk's takeover. So, he introduced a lot of AI first features, and that was the time when AI started to come. AI started booming. So he introduced a lot of AI first features. But what was the biggest change? The for you section in the tab. So if you'll see, if here you will get this for you section in your timeline. And how this for you section works is, so you can divide this into three parts. Basically, first one is candidate sourcing. So it pulls tweets from people you follow, you don't follow, and embedding spaces. And the next step is ranking. So this in ranking it scores tweets based on engagement, relevance, and virality. And they use Apache thrift here. And the final step is filtering, ensuring balanced and spam free content. And based on this, your For You tab is populated. Another one of the most important feature is Grok. Grok is basically their in-house LLM that is integrated in their timeline. So you can think of it like a chat GPT but integrated in your timeline. It personalizes your feed, suggests tweets, and even supports voice integration, but only for premium users. So that was all about this video. If you enjoyed this deep dive into Twitter's tech stack, hit that like button, subscribe for more, and comment below on what should we explore next. Thank you.